come across the word intensity, increase in intensity of light, what does that even mean? For me, to make sense of that word, I could think of the brightness. If you are brightening the same color, I don't know if you get my point. You are brightening, you make the same color bright. Guys, that doesn't mean that I'm increasing frequency. I want you to fully understand what I'm saying to you. If this frequency of light is 5 Hz, let me make an example, 5 Hz. By increasing the brightness of the color, that has nothing to do with increasing the frequency. I'm just increasing the intensity, which is the brightness of the color. I want you to fully understand that, okay? And now, I want to understand, what will the intensity, which is this brightness, affect as soon as this light shines onto a metal surface? The only thing that I'm going to observe is that the number, I want you to hear me clearly, the number of electrons that are emitted per second will increase. The number of electrons that are emitted per second will increase as soon as I increase the what? As soon as I increase the brightness, which is the intensity. But guys, let's not shy away from the fact that if the E photon, which is the energy from the incident light, if that E photon is less than the requirement, which is the work function, guys, we are not going to observe any electrons that are going to be emitted, irregardless of the fact that the intensity has increased. So the rule here is, number one, the E photon, which is the energy from the incident light, must be greater than the work function. Then I'm going to observe electrons emitted. But do take note, in this case, I'm only talking about what? I'm only talking about fewer electrons that are emitted per second. But as soon as I increase the intensity of the same light, guys, the light that is greater than the work function, this is the light that I'm talking about, that's when you're going to observe what? More electrons, more number of electrons that are going to be emitted per second. So the increase in intensity affects the number of electrons that are emitted per second. But the rule is the energy of the photon must be greater than the work function. Please take note of that. Now, when I increase frequency, right? Now I'm increasing frequency. I'm not increasing the intensity. Please take note. I am increasing the frequency. So as soon as I increase the frequency, I am increasing the kinetic energy. It has nothing to do with the number of electrons, but it has something to do with the kinetic energy. As soon as you increase the frequency, you are increasing the kinetic energy of an electron. It has nothing to do, I'm going to repeat that, guys, it has nothing to do with the number of electrons that are emitted per second. But if the same light increases frequency and intensity, that is the only time that I'm going to observe more number of electrons that are emitted per second. I hope that is clear, guys. So intensity affects the number of electrons emitted per second, kinetic energy, and not necessarily kinetic energy, but the increase in frequency affects the kinetic energy of an electron. I hope that is clear, guys. Right. Now I come across the word emission spectra and absorption spectra, and I want to understand what do those two terms mean. Okay. Now, emission spectra, from the word emission, I know I am emitting something, but what is it that I'm emitting? Number one, there must be a hot gas. That is the requirement for emission. There must be a hot gas. Now, when light passes through a hot gas, now I can give you an example of a hot gas to be neon, because neon is known to be a hot gas. So when light passes through neon, which is the hot gas, okay, the electrons that are found in this hot gas, they emit light as they drop from an excited state to a ground state. Now, the reason why I'm saying excited state, the word hot automatically tells you that the gas particles here are moving at random. They have enough kinetic energy. So as soon as light shines through this particular gas, the electrons move or they drop from an excited state to a ground state. Now, when I talk about absorption spectra, this is where I'm going to talk about a cold gas, okay? Now, in a cold gas can be any gas that we know. It can be oxygen, it can be nitrogen. Those can be referred to as cold gases, guys. So, when light passes through a cold gas, okay, what happens is electrons absorb this light. Because remember, when I talk about cold, it means particles are moving at a fixed position, that they don't have enough kinetic energy. So as soon as they receive this light, what happens is they absorb this light as they move from a ground state to an excited state. That is the difference between emission spectra and absorption spectra. Right, now we have reached the end of the lesson, but there's one important thing that I want you to understand, guys. There's what I call Reggie Beef. Reggie Beef. This is a spectrum of colors moving from the color red to the color violet. These colors are important. Why? Because they give me an idea of frequency and wavelength. Okay, remember the relationship between frequency and wavelength is inversely proportional. So meaning an increase in wavelength will result with a decrease in frequency. Please do take note of that. Okay, now say in the exam they gave you two colors. They gave you red and green. Okay, the question that you need to ask yourself is, which color comes before which, and what is the relationship in terms of frequency and wavelength? It always goes down to that, guys, frequency and wavelength. As soon as I know the difference between the two, it's easy. It's going to be very easy for me to answer any question, any exam question, because I know, number one, the red color has the longest wavelength, so meaning the frequency is very low, and then the green color or the yellow color would have a higher frequency, so meaning its wavelength is going to be lower. So if you have to compare between red and green or red and yellow, then it's very important to know how frequency and wavelength are going to affect my colors. Guys, thank you very much, and remember to like and subscribe to my videos. I really appreciate the love that I've been getting, guys. Peace out.